Hi, welcome to my channel and thank you so much for visiting me. This is my very first YouTube video and I created this channel for IB Mathematics. Shortly about myself, my name is Kairat and I study mathematics at a university in Hong Kong. I enjoy solving math problems, and over the past few years I've been teaching mathematics to high school students. And with this channel, my aim is to reach out to as many students as possible around the world who might have any difficulties or problems with understanding mathematical concepts. And if you're one of those students, subscribe to my channel, and if I can bring you any value, that will make me extremely happy. And in the future, I will be uploading more and more content around IB Mathematics. And in this lesson, I will go through one of the past papers for IB higher level mathematics. And I will also include the links below for that paper for you to download. So without any further ado, let's go to the class. Alright guys, so this is November 2013 paper and it has 12 questions. The section A has 9 questions and section B has 3 questions. Section B problems are quite long, they have multiple subparts, but section A problems are shorter, so we have a total of 2 times and we'll solve this past paper as quickly as possible. So let's get into this. So let's go and open the first problem in section A. The problem states that the cubic polynomial 3x cubed plus bx squared plus qx minus 2 has a factor of x plus 2 and leaves a remainder of 4 when divided by x plus 1. Find the value of p and the value of q. So we have to find the value of p and the value of q. So it has a factor of x plus 2. So by the remainder theorem, we have that, let's call this function fx. So it's 3x cubed plus bx squared plus qx minus 2. Now, since x plus 2 is a factor, what we have is f negative 2 is equal to 0, because the theorem states that any polynomial upon division by x minus a leaves a remainder of fa. So here we have the remainder is f negative 2, but since x plus 2 is a factor, it has its value is 0. From the second condition, leaves a remainder of 4 when divided by x plus 1. So from here we have f negative 1 is equal to 4. So from the first condition, it follows that 3 times negative 2 cubed plus p multiplied by negative 2 squared plus q negative 2 minus 2 is equal to 0. And from the second condition, we have 3 negative 1 cubed plus p negative 1 squared plus q negative 1 minus 2 is equal to 4. So now from the first condition, this is equal to negative 24 plus 4p minus 2q minus 2 is equal to 0. From the second condition, we have negative 3 plus p minus q minus 2 is equal to 4. All right, so we have 2 equations and 2 unknowns. First, let's take these numbers to the right-hand side and these 2 numbers. So we have 4p minus 2q is equal to 24 plus 2, which is 26, and p minus q is equal to 4 plus 2 plus 3, which is 9. From here, it follows that 2p minus q is equal to 13, and from here, it follows that p minus q is equal to 9. Now we subtract this part from this equation. What we get is p is equal to 13 minus 9, which is 4, and q is equal to p minus 9, which is negative 5. All right, so these are the answers. P is equal to 4 and Q is equal to -5. Let's go to the next problem. The discrete random variable x has a probability distribution given in this table. Find the value of A. So we know that the sum of the probabilities is equal to 1. So from here, from this formula, what we get is 1/6 plus 1/2 plus 3/10 plus A is equal to 1. So now we take a common denominator to the left-hand side, which will be 30. We multiply this by 5, multiply this by 15, multiply this by 3. Now we get 5 divided by 30 plus 15 divided by 30 plus 9 divided by 30 plus A is equal to 1. So from here we have 5, 15, 9, which is 29 plus 30, 29/30, excuse me, plus A is equal to 1. So now A is equal to 1 minus 29 divided by 30, which is 1 divided by 30. So this is the value of A. Now the second part, part B, find the expected value. The expected value is given by the formula, which is the summation of x. So the sum of x multiplied by the corresponding probability, which is we have 0 multiplied by 1/6 multiplied by 1/6 plus 1 multiplied by 1/2 plus 2 multiplied by 3/10 plus 3 multiplied by A, and which is, this is 0 plus 1/2 plus 6/10 plus 3 multiplied by A, which is 3 divided by 30, and it's equal to 1/2 plus 6/10 plus 1/10. And after calculation, it will be equal to 12/10 or 6/5. So this is the expected value. Now the part C, find the variance. To find the variance, we use this formula. Variance of x is equal to the expected value of x squared minus the expected value of x and the whole thing squared. So I have to calculate this part. Now let me take a new piece of paper. So I will rewrite it here as variance x is equal to ex squared minus ex, the whole thing squared. So now this part will be x squared multiplied by bp equal to x, subtract the expected value squared, and we know this value already, so we calculate this part. And from the condition, which we have here, we multiply 0 squared by 1/6, 0 squared multiplied by 1/6 plus 1 squared multiplied by 1/2 plus 2 squared multiplied by 3/10 plus 2 squared and 3 squared multiplied by A, and subtract expected value squared, which is 6 divided by 5 squared. So now this is 0 plus 1/2 plus 12/10 plus 9 multiplied by 1/30 minus 36 divided by 25. So after calculation, this will be equal to 14/25. So this is the value of variance for the given probability distribution. All right, so the next question, problem 3. The diagram below shows a sketch of the graph of y equal to fx, sketch the graph of y equal to the inverse of f on the same axis. So we know that the graph of the inverse is symmetric to the following line. And this line is y equal to x. The graph has to be symmetrical. So we have a vertical asymptote at 1. We will have a horizontal asymptote at 1. So we have here, this will be the asymptote of the inverse of f. Now, we will have it going like this, and this part seems to be going to 1 as well, so it will be going like this. So this function is the inverse, the graph. All right, state the range of the inverse. Now, from the graph, we can see that the inverse goes from 1 and to infinity and does not include 1. It's because it's the asymptote, and asymptote is not included in the range. So we have range of f inverse is from 1 to positive infinity. All right, so the range looks like this. Part C, given that fx is equal to natural logarithm of ax plus b, x is larger than 1, find the value of a and the value of b. All right, so to solve the part C, what we do is we see that the point 4, 0 lies on the graph of this function. So what we have is ln ax, so 4a plus b is equal to 0. And the other thing we notice is that there is an asymptote at x equal to 1. So what we have is ln a times 1 plus b goes to negative infinity, which means that a plus b equals to 0. And from here, from this equation, we have 4a plus b is equal to 1. Now we have two equations and two unknowns. So we subtract this part from this. What we get is 3a is equal to 1 minus 0, which is 1. So from here, a is 1 over 3. And from the second equation, we will get that b is equal to 2 over 3. So these are the values of a and b. Oh, excuse me, the value of b will be negative 1 divided by 3, because a plus b is 0, a is 1 over 3, and b is negative 1 over 3. I'm sorry. So the values of a is 1 over 3, and the value of b is negative 1 over 3. Let's go to the next problem, problem 4. Oh, there is more space here. Problem 4. Consider the matrix A given in this form. A is not equal to b. Given that A is singular, find the value of A plus B. Now, what does singular mean? Singular means that A does not have an inverse. So this is the meaning of singular. Singular means that A does not have inverse. And we have this formula. A does not have inverse if and only if the determinant of A is equal to 0. So when A doesn't have inverse, we'll have determinant of A is equal to 0, and when determinant of A is equal to 0, we'll have that A does not have inverse. So from this problem, we have that determinant of A must be 0. So from here, the determinant is 1 multiplied by b, b plus 1, minus 1 multiplied by a plus 1. So 1, b, b plus 1, minus 1, a plus 1. Let's expand this, is equal to 0. So from here, we have b squared plus b minus a squared minus a is equal to 0. Now let's take b squared minus a squared to the one part plus b minus a is equal to 0. So b squared minus a squared, there's a formula, b minus a, b plus a plus b minus a squared, b minus a is equal to 0. Now we'll take b minus a outside, like outside the bracket, and we'll have b plus a plus 1 equal to 0. Now we know that a is not equal to b, so this term is not equal to 0. So what we have is that this part is 0. Now b plus a plus 1 is equal to 0, and from here we have a plus b is equal to negative 1. Problem solved. Next problem. A curve has equation x cubed y squared plus x cubed plus minus y cubed plus 9y equal to 0. Find the coordinates of the 3 points on the curve where dy dx is equal to 0. So we have 3 points, we have to find them. Let's apply d dx to both sides. So we have d dx x cubed y squared plus x cubed minus y cubed plus 9y is equal to d dx of 0, which is 0. Now, first we apply the product rule to this term, to this term, and then we differentiate these things. Now, the problem of the implicit differentiation is that it might be a bit confusing sometimes. It involves product rule, it involves the chain rule. But first we have to apply both of them to get the correct answer. So we have d dx with respect to x cubed multiplied by y squared plus d dx with respect to y squared multiplied by x cubed. So this corresponds to this one, and then we apply d dx to x cubed plus d dx to x cubed, and then we apply to y cubed minus d dx y cubed, and then to 9y plus 9 d dx y equals to 0. Now d dx x cubed is 3x squared y squared plus d dx with respect to y squared. What we do here is we apply the chain rule first. We differentiate y squared with respect to y. So we have 2y, and now we have dy dx, and then multiplied by x cubed, plus, this thing is easy, 3x squared, minus, we have y cubed, differentiate with respect to x. So first we differentiate with respect to y. We have 3y squared, and then dy dx, and then plus 9 dy dx is equal to 0. Now we'll take dy dx separately here, dy dx. What we have here is 2y and x cubed. 2y x cubed minus 3y squared plus 9, and then plus these terms, 3x squared y squared plus 3x squared is equal to 0. Now dy dx is equal to 0, so what we have is that this part will be 0, and since the right hand side is also 0, we have that this part is also 0. So 3x squared y squared plus 3x squared is equal to 0. Now we have 3x squared y squared plus 1 is equal to 0. So from here, we know that y squared plus 1 is never 0 because y squared is greater than or equal to 0, and then this whole thing is greater than or equal to 1. So it can never be 0. The only option is that x is equal to 0. So we have x is equal to 0, and putting this value to the initial equation, we have that 0 cubed y squared plus 0 cubed minus y cubed plus 9y is equal to 0. Now we have y cubed minus 9y is equal to 0. Y squared minus 9 is equal to 0. And y minus 3, y plus 3 is equal to 0. So from here we have three values. Y is equal to 0, y is equal to 3, and y is equal to negative 3. So hence we have the problem was find the coordinates of the 3 points on the curve where dy dx is equal to 0. And by the way, dy dx equal to 0 means that at that point the curve will have a horizontal asymptote. And now we have 3 points. The coordinates are 0 and 0, 0 and 3, and 0 and negative 3. Let's go to the next question. Prove by mathematical induction that n cubed plus 1 plus 11n is divisible by 3. So for mathematical induction, the first step is prove for n is equal to 1. Let's check. We'll have 1 cubed plus 11 times 1 is equal to 12, which is divisible by 3. Okay, we have checked. Second step, suppose that n cubed plus 11n is divisible by 3 for some n greater than or equal to 1. And the third step is to prove for n plus 1. So we have n plus 1 cubed plus 11 n plus 1. Let's expand this. N cubed plus 3n squared plus 3n plus 1 plus 11n plus 11, which is n cubed plus, let's take this term and this term together, 11n, and the other terms also together, 3n squared plus 3n, 1 and 11 plus 12. Now we know that from the second step that this is divisible by 3, so let's call it 3m, and then we have 3n squared plus 3n plus 12. Now the whole thing becomes m plus n squared plus n plus 2 plus 4. So because this is the element of integers, we have that n plus 1 cubed plus 11n plus 1 is divisible by 3. Done. All right, so the next question is the sum of the first two terms of geometric series is 10, and the sum of the first 4 terms is 30. Show that the common ratio satisfies this equation. So let the first term be, first term is b, and then let the common ratio be r. Now we have that the sum of the first two terms is b multiplied by 1 minus r squared. 1 minus r is equal to 10. This is the formula for the sum of the first two terms of the geometric series. And the sum of the first 4 terms of the geometric series is given by b 1 minus r4. 1 minus r is equal to 30. Now we divide this equation by this equation. What we get is 1 minus r4 divided by 1 minus r squared is equal to 30 divided by 10, which is 3. Now this is 1 minus r squared, 1 plus r squared divided by 1 minus r squared equal to 3. We can cancel these two. Now we have 1 plus r squared is equal to 3. From here we have r squared is equal to 2. Part A is finished. Part B. Given that r is equal to the root 2, so the common ratio is equal to root 2, find the first term. All right, so to find the first term, what we do is we have the sum of the first two terms is b plus br is equal to 10 here. Now from here it follows that b 1 plus root 2 is equal to 10. So from here it follows that b is equal to 10 divided by 1 plus root 2. Find the sum of the first 10 terms. So the sum of the first 10 terms is given by this formula, 1 minus r to the power of 10 divided by 1 minus r, which is 10 divided by 1 plus root 2 multiplied by 1 minus root 2 to the power of 10, 1 minus root 2. All right, so from here, after calculation, it becomes 10 multiplied by negative 31 and divided by negative 1, which is equal to 310. All right, so this is the answer. We have solved this problem. The answer is 310. So the next problem is prove the trigonometric identity. So we use the double angle formula. So sine x plus y multiplied by sine x minus y is equal to sine x cos y plus cos x sine y, sine x cosine y minus cosine x sine y. And multiplying each term, we have sine x squared multiplied by cosine y squared. And we multiply this term by this term, we get minus. So this is cos y. Okay. We have sine x sine y cos x cos y. Multiply this term by this, we get plus sine x sine y cos x cos y. And then we multiply this by this, we get minus cos squared x and sine squared y. All right, so we can see that these two terms cancel each other. And now we can rewrite this in the following form. Sine squared x and cosine squared y becomes 1 minus sine squared y. And then minus, we can rewrite cosine squared x in the form 1 minus sine squared x multiplied by sine squared y. And then we have sine squared x minus sine squared x sine squared y minus sine squared y, and then minus minus produces plus sine squared x sine squared y. Now these two terms cancel each other. We have sine squared x minus sine squared y. Problem A, part A finished. Part B, given that fx is the following function, find the range of f. Now using the part A, we deduce that fx, for the value of y of pi over 6, we use this formula. Now fx becomes sine squared x minus sine squared pi divided by 6, which is sine squared x minus sine pi over 6 is 1 over 2, so it becomes 1 over 4. Now the range of sine squared x is from 0 to 1 in the following interval. So the range of fx is from negative 1 over 4 to 3 over 4, including these 2 points. All right, so part C, we have gx, the following function, and we need to find the range of g. So cosecant is 1 divided by secant. So we have that gx now is equal to 1 divided by sine x plus pi over 6 and multiplied by 1 divided by sine of x minus pi over 6. So we can see that gx is actually the reciprocal of fx. So it's actually 1 divided by fx. And since the range of fx is from -1/4 to 3/4, we have that the range of 1/fx will be going from -infinity to 1 divided by 1/4, which is -4, and we do not include it. Union 4 divided by 3 and to infinity, because we divide 1 by this value and 1 by this value. Then they will be the endpoints of the interval. So we go to the problem 9. Solve the following equations. Logarithm x minus 2 to the base of 2 is equal to logarithm x squared minus 6x plus 12 to the base of 4. Now, to solve this problem, we will use the following identity. Logarithm of b to the base of a multiplied by logarithm of c to the base of b is equal to logarithm of c to the base of a. Our goal is to make the bases the same. So we have 2 and 4 here, which are not the same. So we have to make them equal. We have to make them either 2 or 4. Now, we will use, let's rewrite this. Log x minus 2 to the base of 2 is equal to log x squared minus 6x plus 12 to the base of 4. Now we multiply both sides by logarithm of 4 to the base of 2 and logarithm of 4 to the base of 2. We know that by using this formula, the right hand side becomes, this is a, b, and c, so it becomes logarithm of x squared minus 6x plus 12 and to the base of 2. These 4's go away. Now we have logarithm of 2 and 4 multiplied by this. We actually know that logarithm of 4 to the base of 2 is 2, and then logarithm of x minus 2 to the base of 2. Now we have made the bases equal. We take this 2 to the power x minus 2 squared is equal to log x squared minus 6x plus 12, 2. Now we have the same base, and so these values are the same. So we have x minus 2 squared is equal to x squared minus 6x plus 12. X squared minus 4x plus 4 is equal to x squared minus 6x plus 12. Now 2x minus 8 is equal to 0, x is equal to 4. Now part B, to solve part B, what we do is we have x to the power of natural logarithm of x is equal to e to the power of natural logarithm of x cubed. So in these type of solve problems, it's better to take natural logarithm to both sides. So we have natural logarithm of x ln x is equal to ln e ln x cubed. Now we have this ln x goes down, so we have ln x multiplied by ln x is equal to, and then this power also goes down to here, ln x cubed, and then we have ln x ln e. but ln e is 1. So we have ln x squared is equal to ln x cubed. From here we have ln x squared, ln x minus 1 is equal to 0. So we have either ln x is equal to 0 or ln x is equal to 1. In this situation, we'll have x is equal to 1, and here we have x is equal to e. So we have two answers, x equal to 1 and x equal to e. Now we have section B. I will leave this problem 10, problem 11, and problem 12 as an exercise. If you have any questions regarding these 3 problems or regarding the section A problems, please let me know in the comments down below, and I will be happy to answer any of your questions, concerns. And if you like this video, please put the thumbs up. I will really appreciate it very much. It will help my channel grow. And also, if you like this channel, please consider subscribing to my channel. And I will see you in the next video. Thanks for watching.